exponential transformation, okay? So exponential transformation, the format for that is going to be f of x equals a, which we talked about yesterday, right? Times b, which we also talked about yesterday. But now it's to the x minus c and plus d. So we're adding two more variables today. Exactly. So just like before, in all of our transformations, have we had A, B, C, D? Yes, we have. So A, B, C, D is still here. Okay. Now, translations. When we have y equals b to the x plus d, d is very important. D tells us where our horizontal asymptote is. Okay. Our D tells us where our horizontal asymptote is. Okay. D is our vertical shift because it's on the vertical. That means it's affecting which variable? Which variable is that? Vertical, up and down? Everybody, somebody? Y, Ms. Jones, the vertical is the Y. It affects our Y. Okay, so if D is greater than 0, meaning positive, that means that to each Y value, we're adding D. If D is less than 0, that means negative. That means to each one of our Y values, we're subtracting. And when we're referring to the Y values, it's the Y values of the parent function. All right, then we have Y equals B to the X minus C. Okay, so B to the X minus C. What did we talk about in the past about our X's? X's are what? X's are liars. X's are lies. X's are liars. So it looks like it's a negative C, but it's actually a positive C. So when it looks like a negative, it's actually a positive, which means that you're adding to each one of your X values. Because it's part of this. We're in transformation. Okay. When it looks like it's a positive C, notice how I'm adding this to emphasize it. It looks like a positive C. That means you're actually subtracting C, which is why it shifts to the right or it shifts to the left. All right. Lastly, we have our A. Our A we talked about yesterday. A not only represents our Y-intercept, which we talked about yesterday, but it also represents our vertical stretch or compression and a reflection. Okay. So here, if A, absolute value of A is greater than 1, it's a vertical stretch. If A is between 0 and 1, it is a vertical compression, but I'm lazy, so I prefer to use the word shrink. If you want to write the word compression, go for it. I won't stop you. Reflection across the x-axis means that your A is negative. So if your A is negative, it's going to cause it to reflect. So basically, my graph is minding its own business with a positive A. So this is if A is positive, and this is if A is negative. And that's a negative A. All right, questions about our transformation rules? Good? No questions, comments, or concerns? Not yet? Okay. Are the rules different than the other functions?
A little bit, not really.
Exactly. Not really. Okay. So we're going to do our first one together as a class. Then the second one you're going to do together at your table. And then the third one you're going to do by yourself. Okay. So here we go. Together, we're going to identify our A, our B, C, D if it's present. Okay. In this case, A is cast with a friendly ghost. So when there's nothing being multiplied, visibly being multiplied, remember that there is a 1 there. So A equals 1 here. Okay. So since A is 1, there's no stretch, no shrink, right? And no reflection. Our B is 2. Our B lets us know whether we're going to have a possible growth or decay. And because B is greater than 1, what is this? I heard someone say it louder. It's a growth, yes. All right, but B can be tricky, and you'll see that in example 3. All right, and then continuing, do we have a C present?
No.
You sure?
Yeah, I was playing.
C is 2. And what does that C tell us? It shift where? To the right. Good job. So shift right. Okay, so there's a couple ways to graph this. Way number 1 is you can graph the parent function and follow the shift. Way number 2 is to use a table and add the shifts. And then way number 3 is to use a calculator, which we're gonna model on number 2. But number 1, we're gonna be the people who use a table. So the parent function here, we talked about on our I do example yesterday, our growth function. And so the function values that came from that graph, we had -1 was 1/2, 0 was 1, and 1 was 2. Right now we do. Nope. Okay, remember this comes from, so your 1, the value of your 1 is based off of your B. And what's our B? 2, right? And then your Y-intercept, your 0, is based off of your A. And what was our A? 1, right? And then your -1 is always the reciprocal of your +1. So instead of 2, it's 1/2, 1/2. Okay, so this is our parent function. Now to our parent function, we want to shift everything to the right. So is that affecting the X or is that affecting the Y? The X. So to each X value, we're going to add 2. So to each one of our X values, we're adding 2. So what is -1 plus 2?
1.
1. So now I'm at 1/2. What's 0 plus 2? 2. So now I'm at 2/1. What's 1 plus 2? So now I'm at 3/2. Okay, because there's no D value, that means D equals 0. So my asymptote is still at the X-axis. Okay, if you watch today's Do Now video, your asymptote is that imaginary line that separates parts of a function, right? The video is about being in the friend zone, about this guy who really likes this girl, but their relationship is asymptotic. Okay, there's a fine line that keeps him in the friend zone. The asymptote. And so there is my function. I'm never going to cross that. I'm going to get as close as I can. We'll never cross. We'll never be. No, I'm comfortable. Oh, which part? All right, so here we go. There's our function. Let's talk about our domain. What is the domain of all exponentials? Negative infinity to positive infinity, right? It's all real numbers. Or I can just write the R, right? My R is a little sketchy, but you get it. My range, what is the range? How low does the function go? 0. So y has to be greater than 0. All right, I cross the y-axis. I just don't know exactly where I cross the y-axis is, but that's okay because you can calculate your x-intercept. I mean your y-intercept. To calculate your y-intercept, that means you let x equal 0. So if we let x equal 0, that gives us 2 to the 0 minus 2. Which equals 2 to the negative 2. And we did this yesterday in our notes. So on our analysis question yesterday, on the left-hand side of your paper, what did we write 2 to the negative 2 to equal? 1/4. So therefore, our intercept is at 0,14. Good job. And we already stated, but just to reiterate, where is our asymptote at? Where is it? Where's that imaginary boundary line? 0 at y equals 0, right? Horizontal asymptotes are y equal. All right, questions, comments, or concerns? Not yet, cool. So what we're gonna do is we're gonna pause and at your table, you can decide whether you're gonna use a table or if you're going to use the calculator, either Desmos or your handheld, and you're gonna work together to find the attributes of this function. So you're gonna identify your A, your B, your C, your D. I'll be nice and I'll remind you about your table. So the parent function values of this work from our I do decay function. So it's -1, 2, 0, 1, and 1 and 1/2. So those are your parent function values. So if you choose to use a table and change the table, here's your table. If you choose to use the graph, then graph. You're gonna graph and analyze the key attributes. Ready, set, break. All right, so we're going to go through it. So your A equal 2, yes? So you know you had a vertical stretch. Your B equaled 1/2. So what do you have? What does the B tell you? It's between 0 and 1. So what does my B tell me? I have a decay, right? You guys say it louder. I heard you. I wanted you to say it with some confidence. There's no C. So if you wanted to, you can write C equals 0. That makes your heart happy. And then there is a D. And what is your D equal? -2. So that means that this is a shift down, right? So it went down 2 units. Okay. So because of this, because it goes down 2 units, that means also your asymptote goes down 2 units. So my asymptote also goes down 2 units. So it's no longer at 0. It's now at -2 because everything gets shifted. Okay. My X's are staying the same, but my Y's are changing, right? So to each Y value, I'm multiplying it by 2 and shifting it down by 2. So what's 2 times 2? 4, and 4 minus 2 is 2. So we're at -1, 2 still. I'm going to go to -1 and go up to 2. Bam. 0 stays the same at 1. What is 1 times 2? 1 times 2 minus 2 gives me 0. So 0 is now at 0, 0. And then a half. What is a half times 2? 1. And then what's 1 minus 2? -1. So we're at 1, then we're gonna go down to -1. If you were a person who did it with the calculator, did you end up with the same 3 points as we did? And I'm gonna draw it. Again, in that friend zone, can't cross the asymptote. Okay, so that's how we use our variables. So the domain is all real numbers. Our range now, what is our lowest point now? Our lowest point is -2. So y is greater than -2. Our intercept is clearly at 0, 0. And our asymptote is at y equals -2. How do we do? Good? All right, cool. So this is the one you're going to quietly do completely by yourself. And I'm going to also encourage you to check yourself, make sure that the graph you came up with. So you're using the 10. So remember the parent function for this guy. So -1, 0, 1, our parent function is 1/10, 1, and 10. That's on our we do example. So do you have to do it with the table? No, if you choose to do it completely in the calculator, I'm okay with it. But choose your poison method. All right, here we go. So yes, your A, what's your A? -3, what's your B? 10. We have no C and we have no D. Agreed? All right, so we have a reflection because of the negative, right? So we know it should be reflected. And we have a vertical stretch because of the 3. Okay, so what that means is that to each one of our y values, we're multiplying by -3, not just 3, but -3. So our asymptote is still at 0 because our D equals 0. I mean, why would you minus 0? We're just gonna multiply. If you have a dime and you spend 3 dimes, you now have negative dimes, right? You have -3/10. So somewhere in here. What's 1 times -3? I was expecting a whole class. -3. Oh my gosh. And then 10 times -3 goes off the chart. So I can't put it on there, right? So my graph is doing this. Going down, 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 down. Okay, so the domain here is still all real numbers. My range this time, instead of 0 being my minimum, what is 0 now? It's my maximum, right? It now goes from -infinity to 0, which means that it has to be written as y is less than 0. So instead of y being greater than 0, y is less than 0. That is an ugly arrow. Okay, my intercept is at 0, -3. My asymptote is at y equals 0. Now this is a tricky one. We thought it was going to be a growth because of our B value, right? But what changed it? The reflection. So it went from being a growth to being a decay. Okay, that reflection affected our B value rule. All right. Okay, so on your exit ticket, all you're doing is you're analyzing them. So paying attention to what your A value is and your B value. Is it a growth or is it a decay? That's all you're doing here. Paying attention to your A values, your transformations, and then you're going to match and compare. Okay, so you'll match it out here. This is going to go on page 138. And then you will have that. We're done. All right. Thanks for a great day.